Hey, students, here's lesson 4.3, nonlinear functions, and let's get started with it. Okay, let's take a look. 4.3 is on page 262. A nonlinear function is a pattern that creates a shape other than a line. Okay, another possible shape could be like a curve, for example. It might create a curve, or a V, or a U. Okay, now remember we learned a little bit earlier, a pattern is any natural thing that you see occurring in either like actually out in nature or just in data that's describing nature by numbers. Okay, so with data it's interesting because when we graph it, then you can actually see like, okay, this information shows that something is getting larger, so it's going up, or it's getting smaller, so it's going down. So you can see those different things when you assign a number to it, putting, of course, numbers in order, and then, putting them in as data. Continuing on, um, we'll go into a lot more detail in later lessons about how certain shapes are created, but I just want to show you how we get the shapes, okay? So the first thing I want to say is that each function has a rule. Now, you remember we made a couple of tables before. Now, those tables were just comparing some numbers, fairly random numbers. In the function table, it was like just counting numbers 1, 2, 3, and so on the x value, or the independent value, and the y value was just, birth dates. In the table that was not a function, it was birth month compared to birth date. Now, there's a relationship between those numbers, but in a typical function, you're going to want to actually have a rule, okay? Now, the rule in the function we made before is whatever the first, second, and third person, in sequence that I ask, they put their birthday down. But most of the time, there's a more direct relationship between the numbers. Now, I'm going to go ahead and fill out this table, but the rule that I'm talking about can be described in words, but it's easiest described if you put it in an equation, okay? Now, when we say the rule, we mean that equation that gives you whatever the y value is. Now, I want to remind you, the x value is called your independent variable. Now, the independent variable here, these are numbers that are already put in. They're not dependent on whatever. So I can go into more detail about that, but for our purposes, usually when you make a table, it's best to just start counting from 0 up, or to do numbers that are close to 0. Like, for example, you can also start at -2, -1, 0, 1, and 2. Okay? Those are very common numbers to use. Why? Because they're easy to graph. Any number will work, but you want to put numbers that are easy to graph if you have to graph them. So we've used the rule 2x is equal to y. I want to remind you, 2x means 2 times x. Okay? So let's see how this rule plays out. If x is 0, then y is 0. Let's make sure. If x is 0, I'm going to go ahead and do that. What does y equal? So 2 times 0 is 0. So therefore y equals 0. Okay? Now in this particular equation, to solve it, since I had the variable already isolated, all I had to do was simplify 2 and the value of x. And the given value of x was 0, so I just substituted 0 for x. So there's no need to jump to both sides because y was already isolated. Now, if we do the same thing using 1, we say 2 times 1 is equal to y. So 2 times 1 is 2. Now let's do 2. 2 times 2 is equal to y. So what's 2 times 2? That would be 4. Okay. And then 2 times 3. If x is 3, we substitute 3 for x. 2 times 3 is 6. And Aaliyah, what would it, oops, sorry, I put it in the wrong place. It's supposed to be 2. What would it be if x is 4? Yep, that's right. It would be 8. Okay, so this would be how we fill in our table. The x values are given, or you can put in convenient numbers. When I say convenient numbers, numbers that are easy to graph. Okay, follow the rule by solving the equation by substituting in each x value until you have filled out your tables with all the y values. So let's go ahead and graph them. And I'm going to come down here to a graph. Okay, so the first point is 0, 0. So start at the origin of my graph, and I go 0 over, then I go 0 up. So basically, I just stay there. Now the second one is 1, 2. So remember, your x value always goes first and your y value goes second. Meaning that when you are graphing, you always count the left to right first, and then before you count the up and down. If you forget that, just remember x comes before y in the alphabet, so it goes first. So if the x value is 1, then I go over to the right 1. The y value is 2, then I go up 2. If the x value is 2, then I go over 2 and up 4. So over 2, up 4. If the x value is 3, I go over 3 and up 6. If the x value is 4, I go over 4 and up 8. Now, as you can see, I have a perfectly straight line. I don't necessarily need to get a fancy ruler or anything, just any straight edge, like another pen, would do. Let me get my pen to sit right. Okay. Now, let's see how this works with a nonlinear function. So with this function, it's very similar. Instead of 2x, it's x2, or x squared, x to the power of 2, okay, equals y. So let's go ahead. If x was 0, then 0 squared would be 0 times 0. Then y would be 0. So the first answer is the same, 0, 0, 0, 0. I'll even graph it right now, first point. So let's do the next one. If x is 1, then 1 squared means 1 times 1, which is 1. Okay. So if x is 2, then 2 to the power of 2 means 2 times 2, which is 4. If x is 3, now this is where people get confused. They go 3 times 3, but then they write 6 because that's 3 plus 3. 3 times 3 is not 6. 3 times 3 is 9. Okay? Because 3 squared means 3 times 3. 4 squared does not mean the game that kids played when they were in like 4th grade. 4 squared means 4 times 4, which would be 16. Okay? So, here's my values. 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. Now let's go ahead and plot them. 0, 0 I already put down. So now I have 1, 1, 2, 4, 3, 9, and 4, 16. I'm going to be way up here somewhere. Now, as you can see, the shape ends up making a curve. Okay? So, with a linear, it makes a line. The nonlinear, it makes another shape. Okay? Now, the real trick to learning this lesson is just being able to figure out where things go. Okay? Sometimes your x values will be given. Sometimes your x values, you may have to come up with them. The x values um, are ones you have to come up with yourself. I would highly recommend using easy x values, meaning numbers that are easy to understand and close to 0, convenient x values. The most highly recommended values to use when you begin graphing are this: -2, -1, 0, 1, and 2. So I recommend using those values unless it states otherwise, or obviously if the x values are given to you. Okay. Now, taking a look at the lesson, and I'll just stick it under here, it does give some different functions. Now, the function mentioned here is each time you create a step, then the number of blocks needed to make the step goes up higher. Okay, so one step, you need 1 block. To make 2 steps, you need 3 blocks because there has to be a block under to support the 1. To make 3 steps, then you need, looks like 6 blocks. So if you do this as a table, you end up with the values 1, 1, 2, 3, 3, 6. And each time you go up, you can probably visually follow the pattern and figure out what 4 and 5 would be. Okay, but every time you have to build more blocks in order to make the number of steps. Any of you that have ever messed around with Legos probably know this. It's like, oh, you got to put a whole bunch of stuff under it to make it sit up right. Relationship is a nonlinear function. Now here's some sample nonlinear functions here. Okay. Here's a curve. Here's kind of an S sort of shape, and here's a V. These ones here are linear. Okay. And I want to remind you, per our instructions from the last lesson, we call it linear if the line is not perfectly vertical, meaning going up and down. Okay, even though it makes a line, it's technically linear, but for our purposes, a linear equation represents a function, and a function cannot have a vertical line. We'll go into more detail later on that. So I'm not going to spend a lot more time, but I just wanted you to kind of see how certain functions occur. So this one is comparing the radius of a pizza to the area in square inches. Okay. Now radius is linear because it's measuring a line. It's a line from the center to the edge of the pizza. Area is square because it's measuring in little squares. Even if it's a circle, it's measuring a circle in little squares. Okay. Now this one, it's the weight in ounces of sauce compared to the cost. So sometimes you're going to get, like in this case, it's a curve when you see the graph of radius versus area. And sometimes it's going to be linear. The cost goes up at the same rate that the weight goes up. Okay. Well, sometimes there might be changes, especially sometimes stores will sell things if you buy a larger amount, then the price will go down. So sometimes there won't be a perfect line. It probably won't be a curve though. It's probably going to be more of like a line that stops and then changes direction. Okay, well, I hope this helps. I highly recommend to read 262 on and look at more of the examples. This lesson's a little bit harder, but I'm going to keep the video short just so that you can get to it. Thank you, and have a great time.